Kia ora. Let's have a look at question number 15, okay? The non-inverting summing amplifier. What on earth does that mean? Well, let's just break it down and think about it. It's an amplifier, so it amplifies the input to the output, right? And it's summing, so that means it's going to add the two inputs, okay? And the two inputs are going to be connected to the non-inverting input. Okay, can you just grasp those ideas that this is a non-inverting, so that means that the inputs are connected to the non-inverting inputs of the amplifier, and they're going to be summed, okay, rather than subtracted. So let's just have a look at the actual schematic here in the simulator. So here's what we've got. Could you recognize this circuit without knowing that description? Is this a inverting or non-inverting? Is it a subtractor, or is it a an adder? Okay. So, or a summing amplifier. So have a think about it. Is it summing them or is it subtracting them? Well, they're both on the same terminal here, so that means that it's summing them, okay? And let's see, is it a non-inverting or inverting? Well, the inputs are connected to the non-inverting input, okay? So therefore what we've got is we've got a summing amplifier which is non-inverting, and we just typically call it a non-inverting summing amplifier. So that's not too hard to get your head around, is it? So let's just have a little think about the actual schematic and how this works. Okay. So what we've got here is in this particular case I've got minus 3.87 volts and I've got minus 1.88 volts. And now I'm going to do a bit of an analysis here. Let me just think about this first of all. What we've got here is we've got the voltage at the non-inverting terminal, and of course we've got voltage at the inverting terminal. These two are equal because of our negative feedback, we know that. And we know that, well, if we look at this and we just hide this bit of the circuit here, first of all, this here is a very, very standard non-inverting op-amp circuit. So we know that the output voltage is V plus times, right, 1 plus R2 over R1. And that's how we get our output voltage, okay? So we know that's 1 plus R2 over R1 for a non-inverting amplifier circuit. But what is V plus in this case? How do we work out V plus? Well, let's just think about that in terms of hiding this part of the circuit here. What have we got? We've got a voltage here which is created by two input voltages hung together with two resistors. Now, we can apply superposition to that really easily, okay? So what we're going to do is if I have one circuit looking like this, and this is V plus here, right? And I've got, say, minus 3.87 volts here. Well, if I zero this one, right, 0 volts, then I can work out this voltage here. I know that's 20k, right? Then I can work out this voltage here because actually it's going to be half of minus 3.87, isn't it? Okay. Now, let's add that to the other part of the superposition, which is to zero the other input. So now we're going to put 0 on this side here, right? And we're going to put minus 1.88 here. There's our V plus, right? And here is our 20k and 20k, right? So they're equal. So therefore, this voltage here will be half of minus 1.88. So I've got minus 1.88 over 2 plus minus 3.87 over 2, okay? So that's my output voltage. Sorry, I'll just scroll this so you can see it now. So we know that the output voltage here is half of the sum of the two input voltages. And then we multiply it by 1 plus this. What we end up with here is a very simple solution, which is V in 1 plus V in 2, right? We've divided that by 2 because that's what we've got with our superposition, and then we're multiplying that by 1 plus R2 over R1, okay? And that's how we get V out. Now, can you look at this and just see the fact that what we're going to get here is R2 over R1. Well, hold on. R2 and R1 are the same, okay? Aren't they the same? So that's times 1 plus 1. V in plus V in 2 over 2 times 1 plus 1 cancels out, okay? So we get in the output voltage as the sum of the two inputs. Does that make sense to you? I hope so. look, there's plenty of explanations on the internet. If you can't quite follow my explanation, you want another one from someone else, just, have a look on the internet and grab another explanation. Sometimes it helps to hear it from a different source as well. But really, when these resistor values are all the same here, what you've got is, when they're all the same, you've got a very simple non-inverting summing amplifier. So it's just going to V out equals V1 plus V2. That's all it is. Hopefully that'll help you just grasp this concept about this, because we're going to use these in circuits later on. It's really useful to be able to understand them now. Okay, cheers.